Hi, I'm Sam Kriegman, and it's my pleasure to present, on behalf of my co-authors, pictured here, our work on automated shape-shifting for function recovery in damaged robots. Much previous work has shown how an autonomous robot, once damaged, can update its controller for its damaged or injured body. For example, through continuous self-modeling, or by traversing a behavioral repertoire, effective gates can be found for the damaged structure. However, these methods only change the controller, not the shape of the robot, which raises the question, can shape change help adapt robots when damaged? To test this, we optimize the robot to move as quickly as possible forward in simulation. And we built in reality using 140 pneumatically actuated silicone voxels. Then, of course, we cut off its legs in simulation and in reality. Ouch. The damaged robot can no longer walk, of course. Next, without changing its controller, the robot takes a new resting shape. But it still can't walk. Eventually, the optimizer finds shape changes that undo the damage. And they were instantiated in the real robot system. This robot recovered function through shape change without touching its control policy. And it was in fact slightly faster than the original robot for which its controller was optimized. In another damage case, we cut off the robot's foot. The horizontal axis is recovery time. The vertical axis is relative displacement, where that gray dotted line at 1 is the displacement of the original machine. The red dashed curve is controller adaptation. The green solid curve is the performance recovered by shape change, which, as you can see, for this particular damage case, is greater than that of controller adaptation. We tested 9 damage scenarios in total, in which we lobbed off ever more limbs and chunks of the robot's body. Overall, correcting for multiple comparisons, shape change recovers more performance than controller adaptation. But let's take a look at a few more examples, because it might seem obvious if you're soft and you lose part of your body, you should deform so as to replace that missing part. But if that's the only option, then optimizing shape change is unnecessary. So is regeneration the only option? Well, when this robot lost a quarter of its body, it found a completely novel geometry that synergized with the original controller to recover forward locomotion. And now I'll show 2 very different recovery strategies for the same damage scenario. When the robot's cut in half. On the top, the robot is about to greatly expand its remnant limbs, contract its spine, and flip over. On the bottom, the robot did the exact opposite in the same scenario. It contracted its limbs, expanded its spine for balance, and it moves in the opposite direction because of its shape change. But they both have the same controller. So for more details about this morphology control distinction that we've made, which I think is pretty natural, and our progress on sim-to-real transferability, please ask a challenging question at the end of this session or come see me at the poster. Thank you.